Parabolas. So just like you guys when we were in Algebra 1 and Algebra 2, and we worked with parabolas, the majority of our parabolas that we dealt with would be an up or a down. And they'd either look like this or it would have looked like that. And they can be shifted up and down the y-axis. It doesn't really matter. But with conics, we can actually have parabolas going right or left. Right is when they're going to be positive, and left is when they're going to be negative. And this is when your y is squared. These are when your x's are squared. The definition of a parabola. A parabola is the set of all points in a plane that are equidistant from a particular line, which is called the directrix, and a particular point, which is called the focus, and they're on that plane. Things that you need to know for this class or for this part is we're going to really focus on the focus, the vertex, and this directrix. The distance between the directrix and the vertex to the focus is a p-value, and that p-value is related to the focal length. These are the standard equations of a parabola in vertex form. The first column has to do with the x being squared, so it's either going to be up or down. The second column has to do with the y being squared, so that's going to be either left or right. Big things that you need to realize is that when it is positive, you're going to be opening up or to the right, depending on who's squared. And when it's negative, you're going to be opening downward or to the left. This is how you find the focus. You use your h's and your k's and your p-value for both of those, depending on where they are. To find your directrix, if it's up and down, you're going to have a y equaling a number. And to find the number, you're going to use this equation. When it's up or down, or left or right, it's going to be an x, a vertical equation. And you're going to use these same values to be able to figure out what that directrix is. You also have an axis of symmetry, and that's what the next one is talking about, the focal length. And we also talk about the focal width when you're graphing those. It's really important to understand the actual width of the focal and its absolute value. So whatever you get for your p value, multiply it by 4 and take the absolute value of it. Okay, here is our first example, and there's some couple things I want to write down to make sure that we have these values, because we don't want to flip back and forth in the table or in the booklet. So the things that I'm going to write down is the x is squared, so I'm going to look at the standard equation for that, and that is x minus h squared equals 4p y minus k. I keep losing internet, that's why it's mark went off on my iPad. It's very strange. So x minus h squared equals 4p y minus k. That's a minus and it doesn't look like it. Because this is negative, I'm opening down. My focus, how I'm going to figure it out, is going to be h comma k plus p. The directrix is going to be y equals your k value minus your p value. And the focal width is going to be that. So let's answer all that we can. Okay, the first part is that we are going to get this guy into this standard form. And currently, the x squared part doesn't have a number in front of it, but currently right now we do. So whenever I have a fraction, I make the other one a fraction and do a proportion. So I get 2y is equal to negative 1x squared. Divide both sides by negative. So we get negative 2y is equal to x squared. So this is the equation. If we want to write it like it does in this, we're going to rewrite it. I might do a little box to kind of keep us focused. I'm going to write x minus 0 squared equals negative 2y.
To clear the hallways. You should be in the classroom for tutorials and practice. Outside waiting on your ride or headed home.
I'm going to pause it, or I'm just going to have to just wait for it, for the music to stop. To find p, we're basically going to set this in the standard equation is equivalent to the 4p. So if we set this equal and solve for p, we now know all the values to help us find this and this and this. So let's start with the focus. Well, the focus says take your h value, which is 0. Got it right there. And then you have your k value plus your p. So when I solve that, I get negative 1/2. So at 0, negative 1/2. So that's one part of the things that I needed to find. To find the directrix, I'm going to go y equals k minus p. My k value was 0. I subtracted a negative 1/2, which made it a positive 1/2. So this is my directrix. And the focal length, actually the focal width, is going to be the absolute value of 4 times negative 1/2, which would give me negative 2, and the absolute value of that would be 2. So I'm just going to sketch this parabola because it is really hard with these numbers as small as they are with 1/2. But here is my directrix. It is at y equaling 1/2. Here is my vertex. Here is my focus. And I'll have a width of 2 at that value that I have, so I'm going to kind of make the parabola kind of do that, sketching wise. Example number 2. Find the standard form of an equation for a parabola with the vertex 3, 5 and a focus of 5, 4. Hint, always sketch the vertex and the focus so you can see whether the parabola is horizontal or vertical. Remember, when you're graphing a parabola, I'll just put it like this. Your directrix and your focus are the same distance apart, that P. But notice they're on opposite sides of that vertex. So it's really important when you look at graphing these 2 points. I know where the vertex is. It's at 3, 4. And the focus is at 5, 4. And I'm having a hard time graphing the point. Let's see if I can get it to do it. So this is my vertex and this is my focus. Then I know that this is my distance of P, so the directrix has to be going this way. Your focus is kind of in the middle of this parabola, or it's in the parabola. So what do I know and what can I fill in? Okay, well, if I look right here, this is going to be a y squared. So I'm going to use the equation y minus k squared equals 4p x minus h. Fill in what you know. You know the x value of your vertex and the y value. I'm going to use the focus point, which is written in this way on our table, to figure it out. I know this value. Keep losing the internet connection. I know that your focus is 5, 4. And I know to find your focus when it's written in a left or right, it's going to be an h plus p equals your k. So I know that my h is a positive 3. and I know my focus, the x value, when I'm solving this, is equal to 5. So this should equal that. When I solve for p, I get p is equal to 2. You also might be able to see that on the graph when you were plotting those 2 points and I showed it on the graph. So now I should be able to write the full equation. I'm going to write it in 2 steps so that you can see. Y minus 4 squared equals 4 times 2, and the actual answer will actually multiply those 4 and 2. Example 3. Hopefully the internet's going to hold out on me because it's really struggling. Okay, so some things I know from this graph. I know this is my vertex, and I know this is my directrix. When I look at the table, if my directrix is an x equaling, I know my y value is going to be squared. So if I go back to the standard form, I know that I'm going to have an equation that is going to be a y minus k squared equals 4p x minus h. I'm going to fill in what I know. I know the vertex, so I'm going to plug that in. You could put the minus 0 or not put the minus 0. I'm going to choose to because it makes it easy to go in and look at what I need to know. Next thing I need to do is calculate the directrix. I can look on the graph and notice that it's a certain value. So I do notice, hopefully you see this, it's right here. Or what I could do is I know the equation for my directrix is x is equal to h minus your p-value. And my h is 0. And I know from my graph that this is -2. So I don't need to move anybody. My p-value gives me a +2. So my equation would be that. Okay, now I'm going to do completing the square with the parabolas. The y is squared, so the equation that I need to get this into would be a y minus k squared equals 4p x minus h. Since these are equal, it doesn't really matter which side. Like you could really write this as 4p similar equations. I did that because I currently want to get the y's by themselves and the number with that x on the other side. So I'm going to move that 20 over. And then just like with circles and ellipses, you can't have that 2 in front of that coefficient or in front of the y squared. So I'm going to factor it out. And I'm going to multiply that and add it to both sides of the equal sign. Half of negative 8 is negative 4. Squared is 16. Negative 72 plus 20x plus 32. I can combine these two. Notice there was something factored out with the x's. So look at the negative 40 and the 20. I'm going to switch the order of it. I'm going to pull out a 20. I'm going to write an x minus 2. If you notice, there was nothing in front of the y squared except for the 1, so I can't have this 2 there. In standard form, I need to divide both sides by 2. So my equation is negative 10 I'm sorry, made an error with that. I'm going to take out a positive 20. Let me fix that real quick. Make my eraser a little bit bigger. Good thing I caught it before I published it. Okay, so let's make it easier. Let's do 20x minus 40 equals 2y minus 4. Now I'm only going to factor out a 20. Anytime I see a negative, I all of a sudden pull them out, and I didn't realize that I didn't need to. Okay, so I'm going to write it just like it is in standard form in your book. Y minus 4 squared equals 10. I got 10 from this. X minus 2. So for your homework, the first 4 problems or 3 problems you're going to be working on finding the focal length or focal width, the focus, and the directrix, and you're using that table. Then you're going to graph using the vertex and the focus. Numbers 5, 6, and 7, you're going to actually take the time to write the equation. On your quiz and test, you'll actually have a grid, but on this one, you're going to have to draw them. Numbers 8 and 9, you're doing the completing the square. And number 10, you are finding the equation for the parabola.